Hello everyone, we are going to talk about green technologies today, and one of the green technology is known as hydroenergy. So hydropower or hydroelectric power is a renewable source of energy that generates power by using a dam or diversion structure to alter the natural flow of river or other body of river. Hydropower relies on the endless, constantly recharging system of water cycle to produce electricity using a fuel, water, that is not reduced or eliminated in the process. There are many types of hydropower facilities, though they all are powered by kinetic energy of flowing water as it moves downstream. Hydropower utilizes turbine and generates electricity, and it converts kinetic energy into electric energy, which is then fed into the electric grid to power homes, business and industries. So basically hydroelectric power stations are converting kinetic energy of water into generation of electricity, right? So these water is mostly utilized through dam, reservoirs or diversion of any water body. So here you can see how exactly the hydropower station works, and they are green technology because they are utilizing renewable source of energy which is known as water. So using water's energy we are generating electricity where water is not wasted, right, as it is a renewable source of energy. So because hydropower uses water to generate electricity, plants are usually located on or near a water source. The energy available from the moving water depends on both the volume of the water flow and the change in elevation. So suppose if the water is flowing from a greater height, it will generate more kinetic energy. So it depends on the volume of flow, like how much amount of water is flowing, and on the elevation. The greater the flow and the higher the height, the more electricity that can be generated. So if the flow is greater, the volume is greater, and it is from a higher altitude or it is from higher elevation, that results into great generation of energy or more generation of energy. At the plant level, water flows through pipe, also known as penstock. So whenever the water is flowing through a pipe which is utilized in hydroelectric power station, the pipe is known as penstock, and then spins the blade in turbine, which in turn spins the generator that ultimately produce electricity. So basically what happens is the kinetic energy of water is utilized to move the turbine. So as the turbine will move, it will generate electricity, right? So most conventional hydroelectric facilities operate this way, including runoff river system and pumped storage system. So what is happening here, I'll just explain you different types of hydro energy power stations. The most common type of hydroelectric power station is an impoundment facility. An impoundment facility, typically a large hydroelectric power station, use a dam to store river water in a reservoir. Water released from the reservoir flows through a turbine, spinning it, which in turn activates a generator to produce electricity. So here the first type of hydroelectric power station uses what? It uses the dam's water. So whatever water is stored in the dam or reservoir, that is utilized to generate electricity. So the water may be released to meet the changing electricity needs or other needs such as flood control, recreation, fish passage and other environmental and water quality needs. So water can be released for different purposes, and that water is utilized to generate electricity, right? So this is a basic hydroelectric power station shown in the figure. So here you can see this is a reservoir. That reservoir, right, it is at a height, fine. So you can see at a height the dam is built up, fine. Then you have a gate, right. So if you want the water to flow, right, you open the gate and the water will flow inside a penstock. Penstock means what? It is a pipe which will take water to the turbine, right. So here the gate is opened, here water is stored. Now as the gate is opened, the water will flow through the penstock. The water will flow through the penstock, and what will happen? It will move the turbine. As it will move the turbine, you have a generator attached to it, right, which will generate electricity. There are transformers, and their transformers are connected to electric grid, and the electricity is transmitted. right? So it's a simple process. A reservoir is there, there is a gate, the water is moved inside a penstock, then the turbine will move, turbine will be connected to generator, generator will produce electricity, and that electricity is transferred to electric grids. Now, diversion. So a diversion, sometimes called a runoff river facility, channels a portion of river through a canal or a penstock to utilize natural decline of riverbed elevation to produce energy. A penstock is a closed conduct that channels the flow of water to turbines with water flow regulated by gates, valves and turbines. A diversion may not require the use of dam. So here basically there is no utilization of dam. Here what is happening, they are utilizing the natural elevation system. So here you can see there is a diversion of water, right? The water is flowing because of the naturally elevated. You can see mountains, the water flowing through mountains, so they are already flowing from a height. So they don't require any reservoir or dam to take it to the height and then move the water, right? So here what is happening, there are natural elevation are present, so the water is flowing, there is a diversion from the main river body. So you can see that water is flowing, and here there is a natural elevation and there is a penstock here which takes the water to the turbine, right? So here there will be a turbine connected, then there will be generator, electricity is generated, and here you can see the electricity is connected, and the water which has moved the turbine, and now it is again connected to the main river bank, right? So here there is a diversion, the water will flow through the penstock, move the turbine, generate electricity, that electricity will be taken off, and the used water will be again thrown into the river bank, river, right? So you can see here the water is collected. Okay. Now pump storage. Now this is another type of hydroelectric power station called pump storage. So another type of hydropower called pump storage hydropower or PSH works like a giant battery. A PSH facility is available to store the electricity generated by other power sources like solar, wind and nuclear for later use. This facility stores energy by pumping water from a reservoir at a lower elevation to a reservoir at higher elevation. When the demand of electricity is low, PSH facility stores the energy by pumping water from the lower reservoir to upper reservoir. During a period of high electricity demand, the water is released back to lower reservoir and turns the turbine and generates electricity. So here you can understand the pump storage by this figure. So basically what is happening, here you have a higher reservoir and here you have a lower reservoir. So at the time when the water is moving from higher to lower reservoir, the turbine is moving and it is generating electricity. Here at that time the demand of electricity is high, so we need to generate electricity faster, right? So what is happening here? Here the water is moving through penstock, turbine is moving, generator is generating electricity and the electricity is passed to the city. Now what is the main idea of pumped storage system? So whenever the demand of electricity is low, right? So there is no high consumption of electricity at that time, utilization of solar energy and wind energy is utilized. Here as I have shown in the figure, solar energy. The electricity generated by solar energy will pump the water from lower reservoir to higher reservoir. So here you can see the arrows. What is happening? Here one pipe is moving lower reservoir, this water to higher reservoir, and again as there is a demand of high electricity or high power, then at that time the water will flow down, generate electricity and it will pass down to the city. So basically solar energy and wind energy are also utilized here to pump the water back to the higher reservoir and generate electricity. So this is the process in pumped hydroelectric power station. Now what is the maintenance process? In order to operate micro hydropower plants in good condition for a longer period, waterway facility, electric equipments, transmission and distribution lines should be maintained adequately. Operators must try to observe even small troubles and prevent accidents of facilities. For this purpose, daily patrols and periodic inspections are essential, and record keeping of those data which are important. Though items and frequency of patrols and inspection should be decided considering the condition of facilities and way of usage. Maintenance of micro hydropower plant is as follows. So basically, when you are running a hydropower electric plant, what you should consider in mind, that you should keep records. There should be periodic patrolling and checking or inspection, as you can say. So one should do a daily patrol, daily visit of the equipments are working properly or not, right? Transmission and distribution of electricity is done properly or not. So they should record all the data of the machine and everything. Special inspection in case of earthquake, flood, heavy rain and accidents, operator must stop operation and inspect facilities, right? So during the time of natural calamities, one should stop the operation and one should observe, right? Record of data should be there. Operators must record result of operation and maintenance of plant. The recording is not only of much help to operators in reminding themselves of operation and maintenance that should be done, but also good data to find out causes of trouble in case of accident. So the record maintenance should always be there, because it can be helpful in terms of whenever there is accident, that why this accident happened. So here there was a problem. So this is all about hydroelectric power station.